5. All right, what is a polynomial? This is a new unit, and it's called polynomials. In fact, it's called higher degree polynomials. You're trying to find the notes right now, and I'm going to hold you accountable for that in about 10, realistically more like 45 seconds. I'm going to ask you to show me that you're in the right spot. Please get there quickly. It is the one that says today's date is assigned. It was assigned on 2/13, and it's due on 2/18. What does that tell you? It actually tells you that you don't have to have it done by tomorrow, because many of you are going to buy your way out of class tomorrow, which is awesome, and enjoy that. But it's due instead not even on Monday, because we don't have school on Monday, in case you forgot. We got the long weekend. And so then Tuesday is when this thing is due. And I'm going to pause for a second and clean up some details here. All right, we're back from the break. This is polynomials. So what is a polynomial? Well, a nomial, if the poly is supposed to be meaning like many, or it can be many, nomial must be the other part, and that's these little chunks. You get how that can be divided up into 3 chunks? Those are called terms. And so this is a 3-term polynomial. So any guesses on what they're called? Trinomial, very good. And if there had been 2 terms, it would be called a binomial. If there's only 1 term, it would be called a monomial. Very good. So this one's a monomial. These guys on the right examples are examples of things that are not polynomials. So you're going to be asked to tell the difference between the 2. How can you tell? What do these guys on the right that are in the box have, or how are they different than the ones on the left? Yes, sir. Yep, that part. X to the 3/4 power. Can you have fraction exponents? Yes, you can. But you can't have them in a polynomial. So polynomials aren't supposed to have weird exponents. What's another kind of weird exponent? When the x is on the bottom. And I'm about to tell you something I want you to write down in your notes. I want you to write down that when x is on the bottom, it's like 1 over x. That means x to the -1 power. I don't know if you knew that before, but when x is on the bottom, that means x is to the -1 power. So that's another weird power, see? So you don't want to have weird powers. You can't have powers of 3/4 or any other fraction, unless it like reduces to a whole number. Like if it was 6, no, if it was 8/4, it would just be 2, and then it's not a fraction anymore. So anyway, fractional exponents are bad, and exponents that are negative are bad. All right, so I'm going to give you one, and you tell me polynomial or not. Yes. It's got a power, and its power is what? Actually, that's a good question. Is it 1 or 0? It's 1. It's 1. Because if it was 0, then the x wouldn't even be there anymore, because anything to the 0 power turns into 1. So if this had been x to the 0, it would just turn into a 1. So if I just give you a number like 6, can that be a polynomial? Interesting question. Yes. Its exponent is 0. Like that. Yes? Yep. So like 7 over x, he said, is that a polynomial? It is. You're right. You told me correctly that that is not a polynomial. Now go ahead with the rest of your question.
So if you had like in the problem with x to the -7, would that?
So if you had like 8x to the -7, for instance, that's the same exact thing as 8 times 7 over x. So either way, not okay. So both of these are not polynomials. Not and not. All right? Okay, so let's move on. One more thing about a whole number like 5. Okay, I said it's a polynomial, and I'm actually going to double check that before the end of my recording, because I might not be right. I know the one thing that this is called a constant, because it doesn't have a variable in it, right? And it is also true that it would be like having x to the 0, but I can't remember if a 0 power is allowed in a polynomial. I'm going to look it up before the end of the video. So, all right, I'm going to move on to the next thing, but question first.
Sort of along the same line. Question, then would x over 7
Would x over 7 be allowed? Yes, because the power that's on the x isn't weird. The x just has a 1 on it, right? And if you're going to do anything different, this would be 1/7 x. And it's okay if the numbers in a polynomial are weird, but the powers can't be weird. All right, so this one is a polynomial. Either way you write it, it'll be a polynomial. Okay, let's move on to degree. The degree in a polynomial is really simple. You just got to look for the biggest degree. I want everybody to show me in a second here that you're on the right page, so get close to the right page. This one's 5x to the second minus 3x plus 2. You just pick the biggest degree, the biggest power. What's the biggest power you see? So this is degree 2. So you could say it's a second degree trinomial. See what I just did there? Okay, I got the 2 is my biggest power, so I knew it was a second degree. And then polynomial, I didn't say polynomial, I said, oh, it's got 3 terms, so it's a trinomial. All right. Now, this one is kind of cool. I want you to get to this page, please. Scroll to it and show me that you're in the right spot. Turn it my way. Pause for a second because there'll be some laggers. Okay, the question was, would, if I had 4x to the third, that would be a third degree monomial. Yes, because it's only got 1 term. Now it's a third degree binomial. And now it's a third degree trinomial because it's got 3 terms. All right, makes sense? Okay, now look at this degree thing. Yours won't pop like mine do, but this one is degree 6. Do you agree? All right. See, degree 6. Interactive. Okay, how about this one? People get used to looking at that first number and saying, oh, it's degree 3. It's usually in front, but it's not always in front. So look at that. X to the 4th is the biggest degree. I agree, it's degree 4. Okay, how about this next degree? Degree 4. And the last degree. All right. So now we're going to talk about the ends of this. If this was a piece of string, would you agree that this is an end and this is an end? All right. And then would you get it if I said that the left end was up and the right end was down? Good. That's the way we're going to say it instead of saying that it's increasing or decreasing on the ends, because that can be really confusing, because this part right here, even though it's up, it is not increasing because we read from left to right. And as you read that from left to right, isn't it going down as you move from left to right? So it's actually decreasing in that little zone. All right. So all we care about on these is up and down. So how would you describe this one? The one you put on the left means the left end. So I'm going to say this one is called up, down, ud. What would the next one be called? Down, down. They're both down. Okay, how about the next one? Up, up. And how about the next one? Down, up. Do you get how I was doing those end values? It's just up and down. It's really pretty simple. Okay, now I can tell you by looking at the equation whether things are going to be up or down. And I want you to give me a crazy equation, and I'll tell you whether it's up or down. Remember, you can include things like negatives. You can include multiple terms. You can include things that have different degrees. Okay? So give me an equation, and I'll tell you if I graphed it, whether it'll be up, down, or down, down, or down, up, or what it is. And then I'm going to try to see if you can figure out the pattern so that you could predict, somebody gives some crazy equation, what the answer would be. All right, so for this little part, I want you to shut your iPads because you do not need your iPads for this. Just pay attention. Get them shut quickly. All right, good. Now, give me an equation. Say it. Negative x to the 16th power. All right, that one is going to be, let me think. I'm going to start with the thing on the right. It's going to be down, and then on the left side, it's also going to be down. All right, give me another equation. It can be more complicated than that. I can handle it. Yes, sir. Just x to the 16th. Ooh, you're trying to like figure out the system. All right. Just x to the 16th would be down and down. It reminds me of the game Mastermind, where you have to like judge from the responses, like what you should guess next. Yes. Y equals x to the 15th. All right, that one would be, let me think, down, up. All right, wait. And actually, I just realized something. I was wrong on one of them. I'm going to fix it. Sorry, that's a big deal. X to the 16th. That should be up. Sorry about that. X to the 15th is not up. I'm positive of that. And yes, I double checked X to the 15th. I did it right. Down, up. All right. If you think you've got it, you can give me a guess, or you can give me another equation and I'll tell you if it's down or up. And if I take a guess and they're wrong, then I'm going to for sure do another equation then. You want to take a guess? All right. Got an equation? Hit me. Another equation. And if you think you've got it, then you'll be able to tell in your head whether you've got it or not by whether or not you get this one right. Go ahead.
X to the power of 5.
Ooh, that's not a polynomial because it's not. It's a fractional exponent. It's not a whole number exponent. So, good try though. It's a very unique equation. Nobody's tried that before. So, way to be different. Yes. Negative x to the 15th, go ahead, plus x to the 3rd, minus 5x squared, minus 27. All right. What? Okay, so the last thing you said was what? All right, and you're right, it's the wrong order, but sometimes we're actually going to do that to you too. So all it really matters is I have to find the one with the biggest exponent, and we usually put that first. But if we don't, you've got to find the one with the biggest exponent because that's crucial. All right, so now let me think. That one is going to be up, down. Now, anybody had a theory on how to tell? You can tell by whether you got that one right. Got a theory?
I like the odd ones, like ones that are like x cubed.
Odd ones are kind of like x cubed. That's true. And the even ones kind of look like parabolas. Now, what do you know from that about up and down? You haven't said the words up and down.
So it's like a negative even one down.
So wait a minute, it's a negative even one. Well, yeah, we saw that right here. But what do you know? What do you know about the? How about this? What do you know about the even ones from what you just said? Make a generalization about even ones. It's kind of like a parabola. What does that mean about its upness and downness? They're going to be the same. And you've got one of the rules. Nice job. If it's even, they will have to be the same. Not necessarily up or down, but they'll have to be the same as each other because they're kind of like a parabola, right? All right, good. Therefore, make the extension on that. What about odd ones?
Then it's going to be like a different
They'll have to be the thing where it goes like, yeah, so what do you want about the ends?
down, up, or up, down.
Down, up, or up, down, and they have to be therefore not the same as each other, and what's that called? Different. All right, good. So if you go to like adopt a puppy and at the little place where they keep all of the shelter puppies and one of them's purple, that one would be different. And you'd say, oh, that's kind of odd, right? Get what I'm doing here? The odd ones are different. See, odd, and they were different than each other. All right. You can dye puppies. It's not illegal. All right. You just don't want to get it on their nose and their... Anyway, okay. I don't recommend you do that at home, just to clarify. All right, so let's move on. If they're odd, they're different. If they're even, they're the same. But yet, how could you tell the difference between these two then? Use logic. The negative. So, don't think of it as flipping it, though. Otherwise, you won't know what to do on this kind that are odd. Yes, if I put in a negative, it would flip them, but here's the way to think of the negative. If there's a negative in front, it will have to be down on the right. It doesn't tell you anything about the left. But a negative in front means it's down on the right-hand side. See that on both of those? All right, let's see if you learned those rules well enough. So what if it said this? Negative x to the 451st power plus, I don't even care about the whole rest of the problem. Get what I'm saying? So when somebody gave me that really big, nasty problem, it really didn't even matter. I was just playing along because the first term's all that matters. The one that has the biggest degree. All right, somebody has a guess that it's up, down. Do you agree? How do you know that they're going to be different? Because it's odd. How do you know that it's down on the right-hand side? All right, good. So then, if you see one that's more normal, negative x to the third plus, I really don't care, you're going to say, oh, the first one, don't actually start on the left, start on the right. On the right side, it's got to be down, right? Down, I shouldn't say right. Down, correct? All right, and then on the left side, it would have to be what? All right. Make sense? All right. Why were the opposite again? Because it's not because of the negative, because of the oddness. All right, that's all right. All right, so let's move on. There are a lot more things we have to know. The next main topic is about increasing and decreasing. Do you get that this graph is increasing during that whole time? How do I describe that mathematically? You describe it with the x values, not with the y values. That's the most important thing. It's all about the x's. So it's increasing from, and you write a little thing, it's increasing from here to here, something comma something. So where does it start increasing? Yes? Very good. To be a little more careful though. Negative infinity. All right. And it increases all the way until it hits that. Don't think about this because we're not doing y values. Only going to be x values inside those parentheses. So from negative infinity until it hits negative 3.6. Another way to see that is like this. It goes from way over here until it hits here. See how that's an x value touching the x-axis? And then it starts from here to here. In this little zone right there to there, it's decreasing. So I'm going to use the x numbers to tell me that. I really should have had this point labeled right here, and last hour we kind of determined that it was at negative 0.8, because it's a little less than negative 1, and negative 10.6. So that point right there is supposed to be that. So then, I'm going to now tell you where it's decreasing. It's decreasing from the x value here, which was, if you can't read it, is negative 3.6, to the x value here, negative 0.8. Negative 3.6 to negative 0.8. Yes, sir. Good question. Do we want brackets or not? This is telling when it's increasing. And you could actually make an argument that it is not increasing anymore when it hits the 3.6. You know, get what I'm saying? Because it's at the very peak. So that's why we use parentheses, because it isn't increasing there anymore because it hit the top. All right, so anyway, use parentheses on all of these. Don't have to worry about parentheses and brackets. Every single problem like this, just use parentheses. All right, is there another spot? Yeah, there is. It's also increasing in here, and that's from the x value, negative 0.8, to the x value, which this spot right here is at 1, 0, right? So the x value is 1. There we go. And then it's decreasing again. Tons of people get this one wrong. I want you to tell me this last part that I'll do with the squiggly red line here. I want you to tell me what you think the answer is for this decreasing. It's a parentheses with a comma. Just see if you can tell. Half of you will get it right and half of you get it wrong, bet. From what to what? Write it down on your iPad. Turn it my way and I'll tell you if you're right or wrong. The last part, the part I squiggled there. Parenthesis, comma, parenthesis. Tell me what you think. Yeah, I got like six different answers already. It's amazing. All right. So, okay. The right one, I don't want to tell you right, wrong, because there's going to be like right, wrong, right, wrong, right, wrong, right, wrong. Okay, I'm going to just tell you why. If you knew it was going from here to there, remember how I did like this? It's like this way. It's like an x distance. Then that might have helped you to keep from saying negative infinity because that's not right. It's going from here, which is where? 1, to forever that way. It's the x number, not how low it goes. So positive infinity, from 1 to positive infinity. Who had it right? Raise your hand if you did. All right, good. All right. Why isn't it negative infinity? Because it's not how low it's going. It's between what numbers is it decreasing. And it's decreasing from here, and it'll be decreasing forever. It's an x thing, and x doesn't go to negative infinity if you go to the right. X is only a negative infinity when you're way over on the left. So it's x numbers. All right. This one. Just tell me that middle section. From this point to this point, what's it doing? And then say from this comma this. It's in a little zone. And turn it my way so I can see what you think. What comma what? All right, more people are getting this one right. Not everybody. All right, I'll tell you. That's right, that's right. That's right. That's right, it's not right. It's right. Right? Remember, x numbers. That's right. That's right. No, wait. Not right. Sorry, one of your numbers is right. That's right. That's right. That's right. You did 2 number. I just zoom in on the 1. I only asked about the middle zone. The middle zone. Right? Right? From the 2 I circled. Between the 2 I circled. Good. All right. Now. Nope. All right. So the 2 things I circled, what are the important parts? The x's. From that to, what's that point? That point is 1 comma 0. What's the x of it? 1. So you should have said from negative 2.1 to 1. And is it increasing or decreasing, by the way? Decreasing. From negative 2.1 to 1. That's what I was looking for, and most people had it. All right. Well, let's move on. I think you get that idea. Actually, cool. That's all I have to teach you. Now, your assignment is kind of weird because it's a big long worksheet, but you only do the first 4 parts out of 6, and they're labeled like section 1, section 2. You want to do the first 4 parts of the worksheet. And I know it looks long, but a lot of your answers are like down, up, and they're really quick and easy. Some of them are like, what degree is this? And you say 3, and you're done. So they're really easy questions, so don't worry about how big the assignment looks. You're only doing the first 4 sections of it, and the questions are easy. And besides that, you got like 5 days to do it, for Pete's sakes, because it isn't due tomorrow, and it's not due on the weekend, of course, and you have Monday off, so yeah, so you got plenty of time. The assignment will say today's date on it. It'll say 2/13 assigned, and it'll say due on 2/18. That's one of the reasons I don't feel like I need to cut it down. So sections 1 through 4 off the worksheet that's assigned today, 2/13. All right, that's all I got for you.